Dear students, welcome to my YouTube channel, and this is Prasanjit Malik. Okay, and we are discussing about the matrices. That is an important topics of mathematical physics for CSIR NET exam basically. अदरवाइज हर कोई एग्जाम में जैसे कि गेट जैम जेस्ट मैट्रिक्स से क्वेश्चंस आता है, ठीक है। लेकिन CSIR नेट के लिए मैट्रिक्स का जो टॉपिक्स है वे बहुत ज़्यादा वेटेज रखता है। आउट ऑफ मैथमेटिकल फिजिक्स एक ना एक क्वेश्चन तो आता ही है। लेकिन वी आर डिस्कसिंग फ्रॉम द वेरी बेसिक्स ऑफ मैट्रिसेस दैट यू ऑलरेडी स्टडीड इन योर 10+2 लेवल, बट I just want to remind you that what are the basic things based on which we can develop our advanced theories also. Okay, so let us continue our discussion on various kinds of matrices. So last class में हमने ये पढ़ा था कि what is transpose of matrices, है ना, and we have solved some questions on matrices based on matrix multiplication, transpose of matrices, ऐसे कुछ questions हम किए थे last class में based on the topics that we have already discussed in the previous videos. Okay, so now let us discuss some more topics today, something like symmetry and antisymmetric matrix, Hermitian, skew Hermitian matrices. These kinds of little bit we have to discuss about. Okay, so what is symmetry matrix? You know, if you have a matrix A, so you can write the transpose of matrix. Suppose if you have a matrix A and the transpose of that matrix, and you know I have already told that how you can find out the transpose of a particular matrix by interchanging the rows and column basically. Okay, so अगर आपके पास एक matrix A है and इसका जो transpose है वो है AT, we can write in this way, है ना। So ये जो A matrix है, when we call this matrix A as symmetric matrix if and only if A transpose is basically equal to A. So if this follow the matrix A, if the matrix A follow this equation, that is transpose of A is equal to A itself, that is the elements of after interchanging the row and column, the elements will be same, है ना। So that is basically we can write for each and every element, that is Aij is equal to basically Aji. Okay, so this is just the definition of symmetric matrix. The matrix for which A transpose is equal to A is called actually symmetric matrices. Now let us take an example. We can take various kinds of example, but let me take a standard example of 3x3 matrix, something like A, B, C, then you can write B, C, D, and then C, D, E. Okay, and if you see this matrix A, and if you change the row and column, you can see the matrix will be same. So you can see from this matrix easily that A is equal to A transpose, and that means that this is a symmetry matrix. Okay, now there is an important thing you should understand, that what is the number of independent elements for a n by n symmetry matrix. So you can write this as a note. Sometimes the MCQ questions can be asked from this concept, but we are not going to prove each and everything here. I have already told that we will prove that thing that will be helpful for your understanding part, but otherwise some informations I will directly provide you, as this is a syllabus for CSIR NET exam. Okay, so let us talk about the important statement, that is the number of independent components, and so write down in your note also, is the number of independent components of n by n symmetric matrix. N by n symmetric matrix is half into n plus 1. So you should remember this result. Okay, this is the number of independent components for n by n matrix. Okay, now let us talk about the skew symmetric matrix, or this is sometimes called the antisymmetric matrix also, or you can write it as antisymmetric matrix. Okay, so sometimes people write in this way also, आप ऐसे भी लिख सकते हो, sometimes question में भी ऐसे ही लिखा रहता है कि what is antisymmetric matrix, है ना। So now that is very simple, as you know that A transpose is equal to A is the definition of symmetric matrix, but if A transpose is equal to minus A, then in that case this is called skew symmetric or antisymmetric matrix. So this is very simple definition. Okay, but you should remember this all these things what I am telling, because for advanced topics this ये जो छोटा छोटा चीज है इसको जरूरत पड़ता है, ठीक है। तब अगर आपका बेसिक कॉन्सेप्ट याद नहीं रहता है तो एडवांस टॉपिक्स में बहुत दिक्कत होता है, इसलिए मैं एकदम बेसिक से डिस्कस कर रहा हूँ। अगर आपके पास मास्टर्स डिग्री है तब भी अगर आप भूल गए हो और अदरवाइज बीएससी और एमएससी सेमेस्टर में अगर आप ठीक से नहीं पढ़ा तो भी ये जो कोर्स है आपका जो डाउट है ये पूरा क्लियर कर देगा। ओके, सो दैट्स व्हाई आई एम स्टार्टिंग फ्रॉम द वेरी बेसिक ऑफ थिंग्स। सो मैं ये बार बार बोल रहा हूँ क्योंकि आप बोरिंग भी फील कर सकते हैं, जो जिनका ये टॉपिक्स अच्छे से आता है वो बोरिंग फील कर सकता है, लेकिन एक बार एटलीस्ट आप रिवाइज कर लो। ओके, थोड़ा थोड़ा हम ऐसे रिवाइज करते करते हम जब एडवांस टॉपिक्स में चला जाएगा हमको पता ही नहीं चलेगा कब हम एडवांस टॉपिक्स में एंटर कर जाएगा। तो इसलिए ये जो चैप्टर्स है अगर आपको आ भी है मतलब आता भी है अच्छे से तब भी यू शुड रिमेंबर, यू शुड रिवाइज अगेन एंड अगेन द थिंग्स। ओके, सो डोंट बी बोर एंड मेक पेशेंस एंड सी द वीडियोस वन बाय वन। ओके, so A transpose is equal to minus A is the definition of skew symmetric matrix. Now let us again take a example as something like 0 B C minus B 0 D and minus C minus D 0. Okay, so this is your matrix which is just a antisymmetric matrix, because if you take the A transpose of this then you will get always minus A. Okay, now one thing you can see from this matrix that the diagonal elements are 0, and this is not for this particular matrix. For any skew symmetric matrix you can see the diagonal elements are 0. So one can write a statement that the principal diagonal elements of a n by n matrix is always 0. Matrix are always 0. And one thing, for antisymmetric matrix the number of independent components is half n into n minus 1. Okay, and the number of independent elements or independent components for n by n antisymmetric matrix or skew symmetric matrix, what you can write, antisymmetric matrix is half n into n minus 1. So this result you should remember also. Now one more thing I want to tell you, that any matrix can be represented as the combination of a symmetric and the antisymmetric matrix, something like this. Okay, suppose if you have a matrix A, and the transpose of this is A transpose. Now you can write the A as a combination of A plus A transpose and A minus A transpose, है ना, and A minus A transpose, but you should write here half. So this is the thing that you can write A, है ना. So that is why sometimes say that every square matrix, so we can conclude that every square matrix can be written as the sum of symmetric and antisymmetric matrix, as the sum of symmetric and antisymmetric matrix. And one more thing, important thing, you can write that if A and B are symmetric matrix, if A and B are symmetric matrix, matrices, then AB will be symmetric. then AB will be symmetric. But when AB will be symmetric, but always it will not hold. When it will hold? Now when A and B is commute each other, and I have told earlier that what is the commutation relation. So symmetry only if and only if, or when, you can write when A and B commute, and you know the commutation relation AB, the commutation relation of AB is nothing but AB minus BA, and if this is 0, that means A and B commute each other. A and B commute each other. This is the condition, so that you can tell that A and B commute each other. Okay, commute each other. Okay, so this is something about symmetric and skew symmetric matrix. Okay, now in the same way we should write about Hermitian matrix and anti-Hermitian matrix. Now we have already discussed about the transpose conjugate. जैसे कि सिमेट्रिक मैट्रिक्स क्या है, सिमेट्रिक मैट्रिक्स इज डिफाइंड बेस्ड ऑन द कॉन्सेप्ट ऑफ ट्रांसपोज, but the Hermitian matrix and as well as the anti-Hermitian matrix is defined on the base of transpose conjugate. And what is the transpose conjugate? You know, मैं पहले ही डिस्कस कर रखा था ये ट्रांसपोज कॉन्जुगेट क्या होते हैं. एक्चुअली मैट्रिक्स का जो एलिमेंट्स है, ईच एंड एवरी एलिमेंट्स को अगर हम कॉम्प्लेक्स कॉन्जुगेट ले ले ईच एंड एवरी एलिमेंट्स को, then if you take the transpose of that matrix, then you will get the transpose conjugate. Otherwise you can take conjugate first then transpose, or first transpose then conjugate, so vice versa you can take. And the condition was and the notation of that Hermitian conjugate was a dagger, something like this. Now suppose if you have a matrix A, and if you take the transpose of this matrix, and then you will take the conjugate of this. Now if you will get the, after operating this, if you get the same matrix, that means A dagger is equal to A. So for which matrix this relation hold, that is called actually Hermitian matrix, है ना, इसको हम Hermitian matrix कहते हैं. This is actually Hermitian matrix. Okay, so we can take the example of a Hermitian matrix also, and for element, each and every element we can write that Aij star is nothing but Aji, है ना. कॉम्प्लेक्स कॉन्जुगेट लेने के बाद भी ये सेम होता है. फॉर एग्जाम्पल लेट अस टेक एन एग्जाम्पल, जैसे कि A इज इक्वल टू, आप ऐसे ले सकते A D E, है ना, फिर D B F and E F C. Now these are, suppose we have take the conjugate transpose of this. Okay, so this is something like this you will get. Okay, so this matrix is nothing but the Hermitian matrix. And about Hermitian matrix, one thing you should remember that ये जो principal diagonal होता है for Hermitian matrix के लिए, ये always real होता है. So that one thing you can write that the principal diagonal elements, principal diagonal elements of a Hermitian matrix is, or R you can write, always real. ये रियल होता है. ये जो ABC दिख रहा है, ये डायगोनल एलिमेंट्स, ये क्या होता है, ये रियल होता है. ठीक है. Similarly for skew Hermitian matrix, what is the definition of skew Hermitian matrix? That is A dagger is equal to minus A. Very simple. So we can write for element Y, that is Aij star is equal to minus Aji. Okay, so this is how you can define the skew Hermitian matrix, and you can take another example of this also, something like matrix A is equal to, let me give you this example, A D E, minus D B F, okay, minus E F C, and now take the conjugate of this element D E and F, A F the minus, है ना. So this is, you can say that this is skew Hermitian matrix. Yes, also you can write on more important property that principal diagonal elements of skew Hermitian matrix are either 0 और क्या होगा, ये प्योरली इमेजिनरी होगा. ठीक है, either 0 और प्योरली इमेजिनरी, दैट इज ABC. ABC क्या होगा, either 0 आइदर जीरो और क्या होगा, प्योरली इमेजिनरी। जैसे हर्मिशियन मैट्रिक्स में क्या था, ये सब प्योर रियल था और प्योरली, बट यहाँ प्योरली इमेजिनरी होगा, इमेजिनरी, अदरवाइज ये जीरो भी हो सकते हैं, ठीक है। So this is the definition of skew Hermitian matrix. And one more important thing, I want to point out that suppose you have a matrix A. Now what will be for matrix IA and what will be for the matrix minus IA? Okay, so if A is Hermitian matrix, then IA and minus IA, these are anti-Hermitian. You should remember. If you multiply the A by I or minus I, then the matrix will be anti-Hermitian. Okay, but if you simply multiply by a scalar number k, then it will remain Hermitian. So you should remember this simple kinds of thing that we will use. This property will be used also for eigenvector eigenvalue problem later. Okay, so now here let us solve a simple problem. So देखो problem क्या है, the product mn of two Hermitian matrix m and n is anti-Hermitian. तो एंटी हर्मिशियन बोल दिया गया, प्रोडक्ट एम एन इज एंटी हर्मिशियन। एंटी हर्मिशियन का मतलब क्या हो गया, एम एन का जो डेगर होगा ये हो जाएगा माइनस एम एन के बराबर। इट फॉलोज दैट, तो ये कौन सा जो ए बी सी डी ऑप्शन में एम एन का जो रिलेशन कौन सा वाला ये फॉलो कर रहा है, हमको यही निकालना होगा। तो देखिए एम एन डेगर ये जो है दिस इज इक्वल टू माइनस एम एन, ठीक है। एंड देखिए ये जो टू हर्मिशियन मैट्रिक्स है, एम एंड एन इज एंटी हर्मिशियन। क्या बोला है, द प्रोडक्ट एम एन ऑफ टू हर्मिशियन मैट्रिक्स। देखिए एम एन जो है, एम एन क्या है, एंटी हर्मिशियन है, लेकिन ये जो एम एंड एन है ना, ये हर्मिशियन मैट्रिक्स है। इसका मतलब क्या हो गया, एम डेगर इज इक्वल टू एम एंड एन डेगर इज ऑल्सो इक्वल टू एन। सो ये एम एन डेगर को हम ऐसे लिख सकते हैं ना कि एन डेगर एम डेगर, ओके, and that is equal to minus mn. Now this n dagger is nothing but n and m dagger is nothing but m is equal to minus mn. So ये हो जाएगा nm plus mn is equal to 0, or you can write this mn plus nm is equal to 0. And remember this is just this mn plus mn nm is just this. So this is our answer, but don't confuse with this because this is just a commute relation. If there is minus sign mn minus nm, है ना, then it is something like it is written something like this. Okay, but if it is second bracket, then you should remember then plus sign is here, and for third bracket this is minus sign is here. Okay, so now this is anti commutation relation. Okay, जैसे ये commutation relation होता है इसको कहते हैं anti commutation. Okay, so now the next problem is the singular and non-singular matrix. This is very simple. If you have a matrix A and if the determinant of A is 0, then this is simply a singular matrix. And if the determinant is not equal to 0, then this is non-singular matrix. Very simple example you can take. There is 1 2 2 1 1 2 3 4 suppose. So ये देखिए ये जो है 4 minus 6 that is minus 2, so this is not equal to 0, so this is actually non singular matrix, है ना। अगर कोई सिंगुलर मैट्रिक्स है, जैसे मान लीजिए 1 हो गया 2, इधर हो गया 1, इधर हो गया 2, तो देखो क्या हो गया 2 minus 2 equal to 0, so this is just a singular matrix. So this is very simple example I have taken here, but you can take more complicated example, but the main concept is that the determinant of that matrix is 0 or not. Okay, if the determinant of the matrix is 0, then that is singular. If not equal to 0, then it is non-singular matrix. Okay, so these are the basic things that I have discussed today. Now in the next class we will discuss adjoint of matrix, cofactor and inverse of matrix. Okay, so then we will finish the first basic parts of our matrix and we will move to the advanced first from eigenvalue and eigenvector problem. Okay, thank you.